You gotta pay attention to your slope, dude.
Starting.
That was a negative 2/3. That was a positive 3/5. Negative 2/3 means you go down to the right 3. Or up 2 and to the left 3. Now it's okay to have a line like that, but except that that's going down 2 and to the left 3, which is a negative divided by a negative, which is a positive. That slope is supposed to be negative. That slope is supposed to be positive.
So if it's negative, you go to the right.
No. That is not what I said at all. It is a negative 2 divided by a positive 3. Rise, run. So down to positive 3 means to the right 3. You could have also done 2 divided by negative 3. That's a negative, right? So rise is up 2, run is left 3. So it depends on the way you look at it. When you look at 5/3, it's either up 5 and to the right 5, or down 5 and to the left 5.
Right, you remember how yesterday it was like equal to?
Yeah.
So when it's equal to, your line is supposed to be what?
Okay. I was saying about
Always
5
going
minutes.
wrong.
We're still gonna have to have that discussion.
It's going the right way.
They need to write
Only
that
thing that's wrong
equation
is
for the boundary line.
it was supposed to be solid.
It's probably solid.
Like the equations for the boundary line on
Yeah.
number 4.
As long as it's supposed to be solid when it's one of these. It's one of them, it's line under, it's supposed to be solid. So when it's like that, yeah, so you got that.
What you mean like that? Should I stop?
I don't know.
See, you know,
Rich.
like-
Oh, yeah.
So now we think we should say it to? What you think we should say it to?
Say, give me what I say.
Like you see a line of arrow, like the ones that make the.
Oh,
yeah, bro. Say up or down.
Yeah.
Cause it's going by, it's going negative. See, negative 2 is a negative, I thought like it's a negative or down. No, once you go up then, like I said, I think, cause like, I know a lot of times we have negative, we go down, but like, you know, I feel like when you talk go down, so I feel like we have a negative go up. Try a point. Zero is a wonder how
You
you,
looking at this one right here?
yeah.
Or if you, oh yeah, I did it. Hold on, what's your y-intercept for this?
Mine is four.
Oh,
Took us a long
I see.
time.
Yeah, here, okay, so now you're at 4. And then
Go down,
you went down 2,
probably 3.
right 3, right? So do you think that that's correct?
Yeah.
Yeah, and why'd you use that shit?
Because, it's not greater than,
It's not,
what you say, what we call it?
Equal to.
Yeah, equal
it's not equal to, right? Okay, so now we have greater than, where would we shade the solutions?
Well,
Why?
because I think when we have it, equal to, we go down, we have that, already then go up.
So we're looking at, so when we're looking at equals, we're looking at either dash or solid. We're looking at- Okay, dash, so then we're looking at shading, we're looking at greater than or less than. So what do you have?
greater than,
Greater than, so what does that tell you to show?
down. No,
What do you think?
up.
And if you're unsure, you can test the point.
That's why I said try 0, 0.
If you're unsure, you can test the point. 0, 0 is always the easiest one. Okay, so let's walk through this a little bit. So I went ahead, because it looks like a lot of you were doing this, converting it to slope-intercept form. We gotta make sure we keep these straight. So for the first one, for number one, for that first inequality, you get y is less than or equal to 5 divided by 3 x plus 15. That's a positive 5 divided by 3. Then for the second one, you get y is greater than negative 2 divided by 3x plus 8. Okay, so this is stuff we have to keep track of. Alright, keep track of the positives and the negatives. So for this first one, the y is less than or equal to 5/3 x plus 15. How can I graph this boundary line? So this one right here, this first one.
What, 15 on the, y-axis?
So 15 is your y-intercept, alright, and then what is our slope?
5 divided by 3.
5 divided by 3. Now, in this situation, it's going to be hard to go up, technically up 5 and to the right 3. That's kind of at the top there. What else can I do? How can I go the other direction?
Negative 5.
Down 5, so
Down 5 over to the left 3.
to the left 3 1. So you can, a negative divided by a negative is a positive. Okay, so then, when I have this, creating this boundary line, is it going to be solid or dashed?
Stop.
Why is it solid?
Because it can be equal to.
It's going to be equal to, good. So how do I do the other one?
You said what?
Now how can I graph the other inequality? One I haven't done yet.
Oh, what says that? So how we do other inequality?
Mm-hmm.
Alright.
So that red one I've written right there.
The one you did. So we'll start at 4, it goes down 2 over 3. As it goes to negative 2.
How'd you get 4?
I got 4 by dividing 9 and 6. No, not yet. 9 and 6. No.
Oh, you're on number 2.
Yeah.
We're talking about number 1 right now.
Oh.
Sorry, we're talking about number 1 right now. So the second inequality for number 1. I already have it written in red right there. So where would we start?
We'll start on the one I did. We'll start on 3. No, 8. We'll start on 8.
8. 8 is the y-intercept, okay?
Yeah.
So, now what is the slope?
The slope is up, up 3 over, up 2 over 3. Yeah, up 2 over 3.
Which direction?
Up and left. No, right. Hold on. You're right. It's down.
So, let's look at it. So, this rise divided by run, what is our rise? Negative 2. Which direction does negative 2 go?
Down.
Down, so down 2, and then which direction for the run?
Right.
Right, how many? 3?
Just said it.
Now, you can also go up 2 and to the left 3. To create that. You can go the opposite way. So now, will this line be solid or dashed?
I thought you said mine was correct. You said I was correct. Hold up. I was different. Yeah, I was way different, no?
See?
Cause you told us all, you talking about do it, you said do this. Do it supposed to cross on the axis?
Yeah, and then which way did you go?
I went up. Cause he told me go up, then go up too.
But if you go up, so what I just said, so we have our slope of negative 2 divided by 3, right? Okay, that's our rise,
That's our run.
that's our run. So you can either go, there are 2 options. You can go down 2 to the right 3,
Okay.
or you can go up 2
Done.
and to the left 3.
Nah.
Because is negative 2 divided by 3 the same as 2 divided by negative 3? Are those two the same? Or equivalent? Yes. So You have to be careful, always pay attention to your signs, okay? So now, this line will be solid or dashed.
Dash,
Why is it dashed?
because it can't be.
Because it can't be equal to, good.
You get the whole thing.
Okay, so now, where would we shade the solutions for these?
You say down for the purple,
Why do we shade down?
because it's,
Beneath the boundary line.
solutions are.
Yeah, so when we're looking at it in slope-intercept, when it's less than, we're gonna shade beneath. And that's when we're looking at it in slope-intercept form. What about this red boundary line? Where do we shade the solutions for that? So y is greater than negative 2 divided by 3x plus 8.
Yeah.
Where? Up, there you said? Why would we shade up? Or above?
Greater than.
It's greater than, and when we're looking at it in slope-intercept, if we see greater than, we know to shade above. So now, where are the solutions for these systems?
Well, they both say.
Well, they're both shaded, so it's, right here we only have shaded purple, up here we've only shaded the red, so where they're both shaded is where it satisfies both of the inequalities. Okay, so that's where we shade both of the solutions. Does everyone see how we did that? Jay, do you understand? You guys see how we did that? Y'all good? Any questions? Now let's look at number 3. Look at it, so at number 2, because we're running out of time, number 2 will follow a very similar process. You will convert both of these into slope-intercept, and I think that's the route all you took, and then look at your inequalities.
Our JSC program hosting a campus drive to benefit the West Alabama Food
Where's
Bank
my point
on
negative?
February 8th through March
Where is that?
1st. Please donate starting on Monday
Yes,
and bring
it's a
some
solution.
canned goods
It's yes?
from your
Why is
pantry
it
to help us out.
This is a solution.
Where is it?
Every Friday
It's
between
right-
classes, the special
it's right
education
there.
classroom will
Is it
be
this one
holding
right here?
Catch a Snack Shack with lots of choices for snacks for $1 each. All proceeds will
this
go
point of
to the
intersection?
classroom in room
So you say
115 or
yes.
next to room 200. Any senior beta club member who would like to run for officer need to see Ms. Fairby by tomorrow. Interested
Why
students must
yes?
be available for officer duties and
Because
they
it's
may not have
solution,
been an
it's on the
officer
boundary
or
line.
national usher site.
It's on both
The
of
elections will be held next
It's on both the
Tuesday.
boundary lines, right? It's a point
The
of
individuals
intersection.
are hosting an information night about the auditions for the 2021/2020 season.
If
It
this
will
line is
be
shaded,
February
it's
9th at the
dashed.
theater at
What
5
does that
p.m.
tell us?
Please bring a parent or
Is that
guardian and
what?
email Ms. Gentili with any questions.
What is-
Thank you and have a great day.
So, make sure everyone heard, so this is our point we're talking about, this is this point of intersection. Alright, so, you think it's yes, because it's on both boundary lines.
Yeah.
But, what is this boundary line being dashed to tell us?
It's not equal to.
It's not
Oh,
equal to.
so-
So are any points on this dashed line a solution?
No, so
Oh,
it can't be.
So it can't be, because it only satisfies, on the solid line is a solution.
So no.
On the dashed line, it is not a solution, so it only satisfies one but not the other. So the answer to that would be no.
Really quickly, I'm just gonna streamline a handful of things. Go ahead and write those notes down. We gotta talk about homework and then come back to something. Got that? Still up there? So please notice this, y'all. 5.6, ready, numbers 5 and 8. Go number 18. Please notice, before you put it up, Craig, on number 18, it's supposed to be y is greater than 4x minus 3. That greater than is missing.
Okay, so.
We all clear on that detail?
Oh,
Wait, it's supposed to be greater than or equal to, or
Just greater than.
it's just
Go-
greater than. I'm just trying to show you that it's greater than.
Just greater than. Secondly, we did not get to number 4, but tonight I need you to work on writing the equations of the boundary lines for number 4. Is that clear?
Yes, sir.
Now, please notice, here are some clear points around that triangle that help you write the equations of those boundary lines. What two things do you probably need in order to write the equations of boundary lines?
Intercept.
A y-intercept and a,
It's,
nope, you don't need an x-intercept.
oh, it's a point.
We have